Welcome to Study Loop.
So they ask us, why do long steam pipes often have one or more relatively large U-shaped sections of pipe? Um, I'm assuming, I'm not exactly sure what they're kind of saying here, but I'm assuming they have kind of an S shape. Well, I guess this is a Z shape or reverse S shape section of pipe. I'm assuming that they mean like that. Not just that because there's really no point of having a pipe where it just comes back to itself. So I'm assuming that they mean this. Um, and so if they mean that, then it's because it's a steam pipe. So again, it's going to, assuming that um, sometimes there's steam in it, sometimes there steam isn't steam in it. It's going to have quite a bit of change of temperature because as the steam goes through, it's going to change the temperature of the pipe wall, and that's going to want it to make it thermally expand. And so if you just have a straight pipe wall and you have it kind of fixed at both ends, you should have a straight pipe, and it wants to thermally expand, it's going to basically have to compress itself. It's going to be under a lot of compression here because it wants to expand, but it can't, and it might actually buckle, like basically was shown in the chapter with the railroad tracks. So like with railroad tracks and other things, you can usually put like a small joint in there, so you can make a little gap. So as one section expands, the other, they can expand and fill this gap. That's again a lot of reason you see the expansion joints. Basically, also in wood furniture too, you have expansion joints because as the wood swells and contracts as it absorbs moisture and dries out, you need expansion joints to allow for that, so that you don't get cracking in the wood or buckling in the wood. So I think this is basically, you can't. The problem is with a pipe, you can't have an expansion joint, right? Because it needs to be continuous. So this is essentially an expansion joint in a steam pipe. And why that is it basically allows the pipe to bend in these regions instead of actually compress. And these pipes are generally going to be much less stiff in bending than they are in to stretch them. So you're going to have less stresses here, um, in these corner regions than if you just had a straight pipe here and it was basically under compression. The other reason I could think of too, if you really do have, we're talking about U sections like this, that would probably be if there was water condensing in there and you wanted to drain the water off. Um, so you'd have, this would be, gravity would be down, and so you'd have this section here where any water that condensed would accumulate at the bottom of this U, and you could then drain it off. So that's another reason that you might have a kind of a U shape in a pipe. I'm not sure what they were really talking about. I think they were meaning about this kind of configuration, to allow for the thermal expansion to happen without producing a whole lot of stress in the pipe. Again, you could also have this kind of configuration where you're actually trying to get any condensed water to accumulate at the low point, so that then you could drain it off. Anyway, that's a couple of reasons.